everything. It affects our natural systems, our human systems, infrastructure, financial systems, and the interactions between the two. So agriculture is a very good example of that. We all need to eat. Massive amounts of climate change the dynamic in the landscape, how and when we can produce food and where. It's also a huge problem to address, again, because it's global. So everyone is contributing to climate change, but everyone is contributing different amounts. And everyone is affected by climate change, but everyone is affected by different amounts. And so you have this very difficult dynamic that's going on around the world, and I'm sure you've probably seen that in the news clips around climate change and negotiations and things like that. As Jim alluded to, probably one of the biggest steps forward globally in the last 20 years through the United Nations Framework Convention on Climate Change. And I highly recommend, having heard all the acronyms here, that if anyone wants to step into a new world of acronyms, climate change is a fantastic place to start. It's a pretty significant agreement because it's the first time that all the countries have come together and actually worked as a group rather than splitting from a developing standpoint. The key points are all countries agreed to try to keep temperature increases below 2 degrees. Now that is very challenging. In fact, some science will suggest that we've already crossed that mark. But to try to do that, assuming the mean, means we have to start cutting emissions massively now, and we actually have to start having net zero emissions by the middle of the century. And that's very different to the current trajectory that we're on. But one of the outcomes that was really positive is 87 countries submitted plans for how they plan to try to reduce their emissions to hit these targets. Now, they're still just plans. They need to be implemented, but that's the first time this has happened. One of the other key aspects that's come up is a sudden push on the need for transparency and accountability. One of the big problems is, in many developing countries in particular, how much emissions are actually being produced, because it's not a simple thing to estimate all the time, especially in the land sector. And that means that it's not always easy to detect what are we actually mitigating against. And these countries also have considerably bigger short-term problems than climate change. So if you say you want a system for addressing poverty, they're more likely to take that over a system for estimating emissions. So the Paris Agreement really focused on trying to get those things in place. And really importantly, there was a push to actually start getting more climate finance available for developing countries, with the plan of $100 billion per year by 2020, every single year, to try to drive both mitigation, reduction of emissions, and adaptation. One thing that most people who don't work in the space a lot don't realise is that land use is actually a huge part of the problem. It's currently 24% of global emissions, mainly driven from deforestation and agricultural practices. More importantly though, in many developing countries it's far more than 70% of their total emissions, and in some cases in Africa you can find it's above 90. So if those countries want to do anything about emissions, the land sector is where it's at. For many of our developing countries, the US, Australia, it's more about coal-fired power stations, but in these countries it's more about land use. One of the key things though is these emissions are also caused by poor land management. So a lot of these emissions are being driven not only just because they're deforesting, but then also ongoing poor land management that continues those emissions into the future. The key point is that land has to be part of the solution. So as I mentioned earlier, we wanted to hit net zero emissions. The only way to do that is to turn the land back into a sink rather than a source. The sink potential is huge, 14 gigatons of CO2 a year. That's roughly two and a half times the total US emissions. So proper policies and thought can actually do a lot, but that is still only a potential. There's still a lot of work to do there. Improving land management will obviously help reduce emissions, but as I pointed out earlier, most of these countries, especially in the developing world, have far bigger problems on their plate. And so what we need are systems that not just do emissions, but also really help them with other issues of food security, agriculture, land use planning. And so it's trying to make sure that a system actually meets all of these criteria, because otherwise a government is very unlikely to keep running it in these countries. All of the action that we need these countries to take in the developing world requires some form of support. The climate finance story comes into this very clearly. Circumstances, but not have to.
多
can change a lot. So what we have here is Landsat data, which is an American satellite, or USA satellite, started in 1972. If you're looking for a really good example, just as a side point on really incredible forward thinking and planning, the Landsat program would have to be in the top 3. They started it in 1972 with a plan to collect and archive this data, and it has not stopped since. Really, really quite remarkable. Anyway, so from all of that data we create maps. We difference those maps to create how the land has changed through time over 35 years. Kenya has 778 million 30 by 30 metre pixels, and given the number of land use classes, there's actually 2 to the power 15 possible changes that every single one of those pixels could go through in that time. Now, the vast majority of those are illogical, but it does show the sorts of volumes that we're looking at when you start stacking these data together. We then need all of the Kenya-specific information. So they have a big measurement program that they're putting in place across their landscape. They then attach their modules to this system so that it can model every single individual pixel. These models require a variety of data. A lot of the time, climate data is a really good example. One of the models that Kenya chose needs daily climate data, and it needs it for 4 variables. So what we have here is around 12,500 climate grids for every single variable, and the model has to run those on a daily time step. So that's running through 12,500 time steps for every single pixel. It then pushes all of the data out into a series of reports, tries to do that automatically because it's not a lot of fun trying to do it manually, and also a whole lot of Kenya-specific information. The key thing is that we are still really struggling with volumes and speed. So the base requirement of data is over 50 terabytes just for Kenya. So to give you an idea, Kenya's about 23 million hectares, so about 1/40th the size of the US. The data actually compresses down into 4 terabytes. We then run it through all of those steps, as I said before. There's well over 500 possible outputs per step. At the moment, around a few petabytes of output data, although that can go thousands of times greater than that if you decided to output all of the outputs every single step for every single pixel. It gets very, very big. So you actually need to aggregate those results into something sensible. And then we actually need a whole lot of business intelligence systems and other things that allow us to pull that together to actually make sense of that data. So, partway through the process of developing this tool, and as I mentioned earlier, we wanted it to be generic, was, well, how do we manage it into the future? Because the SLEEK program is a 3 to 4 year program. At the end of that, the funding finishes. We want this tool to be generic. We can't just let it fall over. So what we were looking for is we really wanted the Flint and any other software we developed for this program to be managed professionally. And this is really, really, really uncommon in the land sector. So without mentioning names of organisations, the typical pattern in the land sector is a donor comes forward to an organisation, they say, can you build me a decision support system or some remote sensing platform? Here's X million dollars for 3 years. Software gets built, people run it for 2 years, there's no more money, software gets put on a shelf, disappears, repeat. Been done dozens of times, and so we really want to avoid that problem. To us, that's why we look straight to open source as the key. We want to make sure also that no one government owns the system. All governments using it have an ability to come in and make requests about how that will get managed. And one of the examples of that is something you can look up called the Global Earthquake Model, which numerous countries collaborate on to keep the core simulator running, and then they attach their own country-specific examples to that, and they all tip in a little bit of money every year to keep it going. But the key thing with this software that's very different is that we really, really, really need strong governance. So it's been mentioned a couple of times before here that the tools that have been developed could underpin financial mechanisms. We're talking about billions and billions of dollars per country. A small bug, a small problem actually causes huge issues. It also underpins countries' commitments going off to the UN and saying we will reduce emissions by this much. If there's a mistake in the code that causes problems, that's going to be a problem for everybody. So we really need a strong governance structure, and that's where we've really been interested in talking to the Linux Foundation in particular, because of all of that experience of how we could actually bring that together and actually do this properly. So a little bit of information on the ongoing activities that we have, just for background, because we are still very much in an early development phase. So the Flint development is ongoing. We're planning on doing the first full run for Kenya at the end of April, but that does not have interfaces or any of those sorts of things. It's driven by our own data formats, text file configurations, those sorts of things. But importantly, the collaboration with the Canadians has allowed us to actually replicate their system in the new system and show that what their system produces is exactly the same as what we're producing, and that provides a high degree of confidence that we're actually getting the same core infrastructure right. We've had a lot of interest from Indonesia to try to move to these tools. They're currently using the Australian system. The Australian system, whilst it does the job for them at the moment, has far too many limitations for them to continuously improve their own national system. So they are looking very actively at something newer, and this is the main one that's available at the moment. As I said before, we're really interested in the governance design. We really need to get involved with the stakeholders much more, including yourselves. And importantly, we need to start putting together some funding proposals. I'm sure that's fairly familiar. Just a very quick list. I've seen lots of logos today, so our list is a fair bit shorter at the moment. But these are the groups that we've largely been collaborating or working with on this. But it's a very different list. Again, you can see there's no private sector up there. There's universities. Baker & McKenzie, the law firm, would come in, but it's under their philanthropic arm. It's largely very science-based at the moment, and it's trying to take it away from that and move it again into an actual operational system. So, as I mentioned at the start, we're really looking for assistance here. And there's three main things that we're looking for. We want collaborators on development. At the moment, there's 2 key developers in Australia, there's 2 in Canada. That's the team that's working on it. So, and we've been working very much on the core systems. We haven't been touching things like interfaces. We haven't built continuous integration systems for this yet. We also haven't built all of the data management systems that are really, really required to underpin this. So there's still a lot to do. So we'd be really interested in collaborating with people on that. As you could probably see from the earlier slides, this requires a lot of compute power, but it doesn't have to run all the time. So it's actually really well suited, potentially, to the cloud. And that is a really interesting part of where we want to take this. The only issue being is that governments are a bit wary of that at the moment that we talk to. So you get this sort of funny situation where they don't want to buy a whole lot of IT equipment, but they don't want to go to the cloud. They want to run everything on a laptop. So there's a bit of work there to think through. And of course, financial support. So there's a website there, an email address, and we also have a little unconference event happening after this session, and we'd really appreciate it if anyone's got thoughts or views